Based on origin and applications, organic pollutants could be broadly grouped in the following categories. Oxygen-demanding pollutants contain biodegradable organic compounds either in suspended, colloidal or dissolved form. Such compounds are found in domestic and municipal sewage, effluent from fruit processing industries, canning industries, slaughterhouses, paper and pulp mills, tanneries, breweries and distilleries. Bacteria consume dissolved oxygen and decompose organic matter. Now the synthetic pollutants such as pesticides. Pesticides are the most familiar and widespread examples of organic pollutants. Pesticides kill organisms and are also undesirable to humans. Out of major concern among pesticides are organochlorine pesticides that are included in the Stockholm Convention as the dirty dozens. These are aldrin, chlordin, dichlorodiphenyl trichloroethane, which is DDT, dieldrin, endrin, heptachlor and hexachlorobenzene. Although usage of these pesticides is banned, they are still used for vector control or illegally, especially in developing nations. Approximately 3.5 million tons of pesticides are utilized annually worldwide, where China is the major contributing country, followed by the United States of America and Argentina, which is increasing rapidly. Annually, India produces over 200,000 metric tons of pesticides. As of October 2019, a total of 292 pesticides were registered in India for use. 30 others have been banned, while 7 are restricted in India. Total pesticide consumption is the highest in Maharashtra, followed by Uttar Pradesh, Punjab and Haryana. On the other hand, per hectare consumption of pesticide was the highest in Punjab, 0.74 kg, followed by Haryana, 0.62 kg and Maharashtra, 0.57 kg during 2016-2017. Pesticides are regulated in India through the Insecticides Act 1968 and Insecticides Rules 1971. The Pesticide Management Bill of 2020 is set to replace previous acts. The other category is industrial chemicals, such as polychlorinated biphenyls, or in short PCBs. PCBs are a group of man-made chemicals. They are oily liquids or solids, clear to yellow in color with no smell or taste. PCBs are very stable mixtures that are resistant to extreme temperature and pressure. PCBs were widely used in electric equipment like capacitors and transformers. They were also used in hydraulic fluids, heat transfer fluids, lubricants and plasticizers. The primary company that made PCBs in the United States was Monsanto Incorporation, mainly using the name Arachlor. Commercial production of PCBs ended in 1977 because of health effects associated with exposure. In 1979, the United States Environmental Protection Agency banned the use of PCBs. However, PCBs are still present in many pre-1979 products. Electronic waste recycling and open burning of waste has been evidenced to be an important emission source of PCBs, primarily in developing nations. Like OCPs, PCBs were also included in the list of dirty dozens by the Stockholm Convention. The other category of industrial chemicals, these are plasticizers and additives. Plasticizers are added to brittle plastic products in order to make them more elastic and more suitable for their respective applications. They are used in many plastic parts in everyday life and are also an additive in construction materials such as paints and coatings, sealants, adhesives and plastic windows. There are over thousands of various plasticizers, out of which phthalates constitutes more than 84% of the total plasticizers market globally. Due to their possible teratogenic, mutagenic and carcinogenic effects, phthalic acid esters are classified as priority pollutants by the United States Environmental Protection Agency and several other countries as well. Although several regulatory measures have been initiated at local, regional and global levels to control the production and use of some of these chemicals, phthalic acid esters use is not regulated in Asia. Next comes the category of the phenolic compounds. Phenolic compounds are among the chemicals of major concern in this regard, as they tend to persist in the environment over a long period of time, accumulate and exert toxic effects on humans and animals. The entrance of phenolic compounds in the aquatic environment results from natural, industrial, domestic, and agricultural activities. Their presence may be due to the degradation or decomposition of natural organic matter present in the water, through the disposal of industrial and domestic waste into water bodies, and through runoffs from agricultural lands. These chemicals, upon entry into the water, have the tendency of undergoing transformations into other moieties that can even be more harmful than the original compounds. Phenolic compounds have been enlisted by the US EPA and European Union as the priority pollutants of concern. This enlistment is due to the fact that these chemicals are noted to be toxic and have severe short and long-term effects on humans and animals. Now, the other category of organic contaminants, which are very important because we are using it in our daily life, these are pharmaceuticals and personal care products. Pharmaceuticals and personal care products are a unique group of emerging environmental contaminants due to their inherent ability to induce physiological effects in human at low doses. Pharmaceuticals are defined as prescription, over-the-counter and veterinary therapeutic drugs used to prevent or treat human and animal diseases, while personal care products are used mainly to improve the quality of daily life. Over the past few years, there has been increasing awareness of the unintentional presence of pharmaceutical and personal care products, which are also called PPCPs, in various compartments of the aquatic environment, such as water, sediment, and biota, at concentrations capable of causing detrimental effects to the aquatic organisms. Priority pollutant lists have been developed both by the European Union and the US EPA, identifying a wide variety of chemicals present in wastewaters and stormwater runoff that may pose a serious threat to receiving water bodies, including surface water. In the year 2000, an initial list of 33 priority substances was identified under the EU Water Framework Directive 2060/EC to be used as a control measure for the next 20 years. In 2007, PPCPs such as diclofenac, iopamidol, masks and carbamazepine were identified as future emerging priority candidates. Ibuprofen, chlorofluoric acid, triclosan are proposed additions to the list. There is this another category of pollutants which are not manufactured or not released from waste or products, but these are unintentionally produced during incomplete combustion processes. These are the polychlorinated dibenzopyridioxins, in short called PCDDs, and polychlorinated dibenzofurans, PCDFs. These are two series of almost planar tricyclic aromatic compounds with very similar chemical properties and are the most toxic organic pollutants. PCDDs and PCDFs are not commercially produced but are formed as trace amounts of undesired impurities in the manufacture of other chemicals such as chlorinated phenols and their derivatives, chlorinated diphenyl ethers, and polychlorinated biphenyls. Ongoing or earlier use of pentachlorophenol is considered to be a major source of PCDDs and PCDFs in many industrialized countries. PCDDs and PCDFs are also formed in combustion processes such as waste incineration and in production of iron and steel. Chlorine leaching of pulp and paper has also been an important source, and low concentrations of PCDDs and PCDFs have been found in the earlier paper products. Chlorine alkali plants using graphite electrodes have been identified as a point source. And car exhaust, mainly exhaust from leaded petrol in which chlorinated solvents have been used as so-called scavengers, also produce this set of compounds. Although a variety of sources of PCDDs and PCDFs have been identified, including sewage sludge and garden compost in which they are formed naturally, there may well be substantial fraction that originates from unidentified sources. There are these new sources for PCDDFS in developing countries, such as open burning of municipal solid waste, and as well as in the informal e-waste recycling sector, this compound has been found to be released during the different crude recycling processes. The next category of compound are the polycyclic aromatic hydrocarbons. These are a large group of organic compounds with two or more fused aromatic rings. They have a relatively low solubility in water but are highly lipophilic. Most of the polycyclic aromatic hydrocarbons, which are also known as PHs, these PHs with low vapor pressure in the air are adsorbed onto particles. PAHs are formed mainly as a result of pyrolytic processes, especially the incomplete combustion of organic materials during industrial and other human activities, such as processing of coal and crude oil, combustion of natural gas, including heating, combustion of refuse, vehicle traffic, cooking, and tobacco smoking, as well as natural processes such as carbonization. Tobacco smoke contains variety of PAHs such as benzoapyrene and more than 40 known or suspected human carcinogens. Other route of exposure is through foodstuffs. Barbecuing food over charcoal, wood or other type greatly increases the concentration of PAHs. PAH's effect on human health can be divided to acute or short-term effects and chronic or long-term effects. Occupational exposures to high levels of mixtures containing PHs have resulted in symptoms such as eye irritation, nausea, vomiting, diarrhea, and confusion. Mixtures of PHs are also known to cause skin irritation and inflammation. Health effects from chronic to long-term exposure of PHs may include decreased immune functions, cataracts, kidney and liver damage, asthma-like symptoms. There is this other category of persistent organic pollutants which are called the newly enlisted persistent organic pollutants. In 2017, 16 additional POPs were added by 181 parties under the Stockholm Convention. These new POPs are widely used as pesticides, flame retardants, surfactants, and plasticizers. Industrial POPs such as polychlorinated naphthalines, perfluorooctanoic acid, its salts, and the PFOA related compounds, short chain chlorinated paraffins, tetrabromodiphenyl ether and pentabromodiphenyl ether, decabromodiphenyl ether. Pesticidal POPs include chlorodecone, dicofol, hexachlorobutadiene, alpha hexachlorocyclohexane, beta hexachlorocyclohexane, linden, pentachlorophenol and its salts and esters, endosulfan. Pesticidal and industrial POPs include pentachlorobenzene, perfluorooctane sulfonic acid, its salts, and perfluorooctane sulfonyl fluoride. Unintentional POPs include hexachlorobutadiene, pentachlorobenzene, and polychlorinated naphthalines. Let us now talk about the synthetic compounds, synthetic organic pollutants. Plastics. Plastic has raised many concerns during the last 2 decades for the large diffusion in daily life and its impact on the environment. The development of modern plastics expanded with a large range of types and forms, including natural polymers, modified natural polymers, thermosetting plastics, thermoplastics, and more recently, biodegradable plastics, as stated by Andrade and Neal 2009. Plastics can be used at a wide variety of range of temperatures. They are chemical and light resistant, very strong and tough, but can be easily worked as a hot melt. This versatility, together with the low cost of production, explains the reason of the large diffusion and annual worldwide demand of plastics. It is estimated that 8,300 million metric tons as of virgin plastics have been produced till 2015, with approximately 6,300 metric ton of plastic waste generated, out of which around 9% had been recycled, 12% was incinerated, and 79% was accumulated in landfills or the natural environment. When released into the environment, plastics fulfill some criteria for POPs in that they are organic substances, they persist and accumulate in the environment and organisms over long periods, and they can cause a wide range of sublethal and lethal effects, including the complex toxicology of micrometer to nanometer sized plastic particles coming to light recently. Unlike POPs, which are being phased out under the Stockholm Convention, the production and subsequent release into the environment are continuing to rise significantly for plastics. Plastics make up an even broader category of thousands of combinations of polymers and additives that are used in nearly every aspect of our daily lives, with many critically important applications and with better options for recycling and safe disposal. Plastic enters into the environment through numerous sources. Many everyday activities contribute to innumerate quantities of micro and nanoplastics in the environment. Unfortunately, it is challenging to remove micro and nanoplastics once they enter freshwater and wastewater.